As human beings, our team just needs to sometimes take a week off, and last week was our week to catch our breath, go out and catch some light from our nearest star, and work on some projects that otherwise just don't get enough attention. And during our week off, all sorts of amazing things happened. And today we're going to try and cram a lot of news into not enough minutes. We have stars blowing dust rings, stars exploding, planets preparing to have geysers, rockets going up, and rockets failing to go up. Hold on to your seats. We're going to talk fast as we bring you all this and more, right here on the Daily Space. I am your host, Dr. Pamela Gay, and we are here to put science in your brain. A few weeks ago, we brought you a stunning image produced by Judy Schmidt using brand new images from JWST. At the time, we didn't know exactly what science would come from that data, and I thought we'd be waiting until at least Christmas to get an explanation of how these rings formed. Well, I'm super pleased to say I was super wrong. Those science results came out in the latest issue of Nature in a paper led by Ryan Lau. Here's what they report we're seeing. At the core of at least 17 concentric shells of dust are two stars, a carbon-rich Wolf-Rayet star, WR140, and a hot O-type star. These two massive stars are in a highly eccentric orbit. That means the orbits are super elliptical. And these orbits bring them close together every 7.93 years. Like all Wolf-Rayet stars, this star, WR140, is generating dust. But instead of shedding it fairly continuously, its dust is blasted off by its hot companion every time they sweep past each other, every 7.93 years. The 17 shells we see were emitted over 130 years. Formed of carbon dust, these rings are rich in carbon dust and organic molecules formed from the carbon from the star. Rarely do we get to see anything happen on human timescales, but the short-lived massive stars are giving us a rare and wonderful show we can actually watch evolve. Here's where I hope that JWST functions long enough to allow us to see new shells form and evolve over several 7.93-year cycles. Massive stars like those in WR140 burn through their fuel quickly and have the potential to end their lives as brilliant supernova. Right now, the red giant Betelgeuse is rising in the late evening. Of all the stars we can see with our eyes, Betelgeuse is the one closest to going supernova. But in all likelihood, it won't go boom for many hundred thousands of years. When we start using telescopes, however, there are a whole lot more stars to see and to potentially see explode. The trick is figuring out which ones we need to watch. A new paper in Monthly Notices of the Royal Astronomical Society that is led by Benjamin Davies, however, gives us an early warning sign to watch for. According to this paper, red giants will shed their outermost atmosphere, and this material will hide their light, making them appear 100 times fainter in visible light. Now, we just need a survey focused on looking for stars that fade away, so we can focus in on them to catch every stage of a soon-to-erupt supernova. This new early warning system, however, couldn't have warned about the massive gamma-ray burst that was detected on October 9th. We know detailed science papers will be coming out in the near future. For now, here is what we know. A wave of high-energy light, X-rays and gamma rays, swept across the detectors of Fermi, Swift, Wind, and NICER. Telescopes around the world quickly turned to this source, and imaging revealed a fast-fading point of light shining from what we assume was a star dying 1.9 billion years ago. In the grand scheme of the universe, though, 1.9 billion light-years away is right next door, and the images captured in the 10 hours after first detection are going to reveal never-before-seen details to serve as a check on our models of how gamma-ray bursts should behave. And this wasn't any gamma-ray burst. According to Roberta Pillera, a Fermi-LAT collaboration member, it's also among the most energetic and luminous bursts ever seen, regardless of distance, making it doubly exciting. I really look forward to all the new science this high-energy event is going to bring us. And when it is published, we'll bring it to you right here at the Daily Space. For now, though, we're going to switch gears and look at the goings-on around our solar system. Stay tuned. One of the biggest planetary stories from last week was the announcement by NASA of the preliminary results of the DART mission's impact of asteroid Dimorphos. With much fanfare and a press conference, NASA shared that the spacecraft altered the asteroid's orbit, successfully completing the first full-scale demonstration of this particular form of planetary protection. I'm pretty sure most of the science community expected that we'd managed to alter the asteroid's orbit after witnessing the amazing puff of material and 10,000-kilometer-long dust trail. What was not expected was the degree to which Dimorphos's orbit was altered. The minimum success for the mission was a whopping change of 73 seconds per orbit around its parent asteroid. Dimorphos orbits Didymos in 11 hours and 55 minutes, which means 73 seconds wouldn't have been a very big difference, and it was going to be really hard to detect. However, after careful measurements by the investigation team using a variety of ground-based telescopes, we learned Dimorphos's orbit was now 11 hours 23 minutes, a change of 32 minutes, not seconds. Lori Glaze, director of NASA's Planetary Science Division, notes, quote, "This result is one important step toward understanding the full effect of DART's impact with its target asteroid. As new data comes in each day, astronomers will be able to better assess whether and how a mission like DART could be used in the future to help protect Earth from a collision with an asteroid if we ever discover one headed our way." End quote. It's pretty impressive for a first demonstration. We look forward to more results over the coming months and years as the data is analyzed. And don't forget, ESA's Hera spacecraft arrives to conduct detailed surveys of the system in about 4 years. In other asteroid mission news, researchers at Curtin University were asked by NASA to make observations of the Lucy spacecraft over this past weekend. Lucy is on its way to observe a handful of asteroids known as Trojan asteroids that are orbiting in 2 of Jupiter's Lagrange points. Planetary scientist Eleanor Sampson explained that Curtin's Desert Fireball network would capture footage during the close pass of Lucy on Sunday, October 16th. She noted, quote, "After traveling at about 108,000 kilometers per hour around the Sun, Lucy will come back towards the Earth this weekend for the spacecraft's first gravity assist since launching on October 16th last year." End quote. The video capture was a success for the team, and we'll have a link to their video in our show notes at dailyspace.org. Another mission we're keeping an eye on is NASA's InSight. The CANDO lander, which was plagued by a variety of issues but kept on ticking and tracking wind and quakes, is approaching the end of its mission as dust continues to collect on the solar panels. A recent dust storm that started out 3,500 kilometers away from the lander in September became a global storm that eventually increased the haze by 40% over InSight. Sadly, this means that with even less solar power, InSight's seismometer has been turned off for a couple of weeks. Project manager Chuck Scott is cautiously optimistic, saying, quote, "If we can ride this out, we can keep operating into winter, but I'd worry about the next storm that comes along," end quote. The lander has already far surpassed its primary mission and has been well into its extended mission, measuring Mars quakes and learning more about the Martian interior. We'll be sad to see InSight's mission end. We are excited to see what breakthroughs the already collected data will continue to bring. Moving farther out into our solar system, we turn now to Jupiter's moon, Europa, which likely has a global subsurface ocean that could be habitable. For that reason, NASA is sending the Europa Clipper spacecraft to collect data on the icy moon and possibly even sample some of the plumes that erupt from the surface. Now, in a new paper in the Planetary Science Journal led by Elodie Lesage, computer models of Europa support the hypothesis that those plumes could be a vapor of some type of flowing slushy ice. And if those types of eruptions are occurring on Europa, they probably come from shallow, wide lakes embedded in the ice rather than from subsurface oceans. Lesage explains, quote, "We demonstrated that plumes of cryolava flows could mean that there are shallow liquid reservoirs below, which Europa Clipper would be able to detect. Our results give new insights into how deep the water might be that's driving surface activity, including plumes. And the water should be shallow enough that it can be detected by multiple Europa Clipper instruments," end quote. The model suggests that the eruptions come from reservoirs in the uppermost 4 to 8 kilometers of the crust. At this depth, the ice that essentially encases Europa is at its coldest and most brittle. And as those pockets of water freeze, they expand and cause cracks in that ice. Those cracks then lead to eruptions, allowing the pockets of water to burst out in wide, flat swaths. Deeper reservoirs would push against the warmer surrounding ice, which then acts like a cushion and absorbs the pressure of the expansion rather than cracking and erupting. To really understand just what is occurring with these eruptions, we will have to wait for Europa Clipper to arrive in 2030 and take observations of the surface during its roughly 50 flybys. I'm still rooting for space whales. And now we switch to rockets. Stay tuned. We were off last week, so the launches that we would have talked about on last Tuesday's show were written up for the website instead. You can go there to read all about them, including a SpaceX launch that wasn't a batch of Starlinks, and even a Chinese launch from an ocean platform. Now, let's start this week with the not-so-good launch. On October 11th, UTC, October 12th in Japan, a Japanese Epsilon rocket launched the RAISE 3 mission from the Uchinora Space Center in southern Japan. The JAXA webcasts are always fun to watch, and this was no different, with the three hosts talking excitedly about the payloads on the mission with the rocket itself in the background. This was the 6th flight of an Epsilon rocket overall, and the 5th of the Epsilon S variant. The 8 payloads included the Rapid Innovative Payload Demonstration Satellite, RAISE, 3 primary satellites, and 2 radar satellites for the Japanese company IQPS. Rounding out the satellites on board were 5 CubeSats from Japanese universities. The all-solid vehicle took off from the pad right on schedule, and all appeared nominal through first-stage burnout. The webcast continued on through the point of third stage ignition, showing a map of the rocket's track. Then the webcast unexpectedly switched back to the empty pad at the scheduled time of the third stage ignition. The no longer excited hosts came back on to announce the end of the webcast and told viewers to look for updates on JAXA's website, none of which is a good sign for any launch. A post-launch press conference confirmed that the telemetry showed the rocket's attitude was wrong at the moment of the first stage shutdown. Instead of having the rocket go off course, JAXA triggered the flight termination system prior to separation and ignition of the next stages. Now, about the satellites that should have been put into orbit. Like RAISE 1 and 2, RAISE 3 was developed to test a variety of small instruments on one platform. RAISE 3 contained 7 instruments, including a transmitter for Internet of Things devices, a new thruster that used water as a propellant, and a deorbit sail sized for microsatellites. QPSR-3 and 4 were supposed to be the first operational satellites for IQPS's constellation. The 5 university CubeSats included 2 that were going to test proximity operations between small sats, useful for Earth observation, 1 that was testing off-the-shelf parts for semiconductors in space, and 1 that was 3D printed as a single piece, and 1 that was going to study the Earth's crust under the seafloor. While we will miss the opportunities those satellites could have brought us to do science, the next day there was a more successful launch. On October 12th, in the same part of the world, a Chinese Long March 2C launched the SR-01 satellite into orbit from the Haiyuan Launch Center in China. SR-01 is a radar satellite that will produce 5-meter resolution imagery for the Chinese government's Ministry of Emergency Management and Ministry of Ecology and the Environment. According to the China National Space Administration, the satellite will be used for disaster relief, environmental protection, and natural resource management. The latter includes agriculture, water conservancy, and forestry. On October 14th, China also launched 3 Yaogan satellites from the Yaogan 36 series on a Long March 2D. The Yaogan series typically have military purposes, so not much was said about the launch other than that it was successful. SpaceX continued a string of launching other people's satellites with Hotbird 13F on October 15th. Eutelsat of France contracted SpaceX to launch several new C-band communication satellites before December 2023. Their first satellite launched this week, Hotbird 13F. Hotbird 13F and its sister satellite 13G will replace 3 older satellites at the 13 degrees east position. Hotbird 13F launched on booster 1069 from Slick 40 at the Cape Canaveral Space Force Station. 1069 was on just its 3rd flight and successfully landed on the drone ship. Just read the instructions, 9 minutes after launch. There was no spectacular plume like a previous launch, but the webcast managed to show video for most of the landing process as usual. The Falcon 9 second stage released Hotbird 13F into a geostationary transfer orbit after a short coast phase and 1-minute duration second burn of the engine. The satellite's xenon engines will do the rest of the work to deliver it to its geostationary orbit. Hotbird 13G will join 13F in orbit as early as November. SpaceX continued a busy week with the return of 4 astronauts of the Crew 4 mission from the ISS to Earth on October 15th. Breaking from routine, Crew Dragon Freedom undocked the same day as its deorbit and returned to Earth only 5 hours after undocking. Crew Dragon undocked just after noon Eastern on the 15th. Just before 1600 Eastern, the deorbit burn was completed. Unlike Soyuz, Crew Dragon does its deorbit burn without the service section attached, leaving it to return uncontrolled after several months of atmospheric drag. The reason this is done is to avoid any problems that could result from separating the trunk after the burn, such as interfering with the heat shield during reentry. Freedom splashed down off the coast of Jacksonville, Florida at 16:55 Eastern, within sight of the waiting recovery vessels. The ship lifted it out of the water and each crew member was brought out in turn. With the landing, NASA's Kjell Lindgren has now spent 311 days in space on 2 missions, and ESA's Samantha Cristoforti 369 days, making her number 2 on the list of most time spent in space by a woman. Jessica Watkins completed her first trip into space and has already set a record for most time in space by an African American woman at 170 days. Rounding out the crew was Bob Hines, who was on his first mission in space. Finally, Russia also launched 2 rockets last week, one carrying a commercial payload and the other a military payload. Before we go, I just want to draw your attention to one final thing. There's a new space race in town. SpaceX has announced plans to try and launch their Starship into orbit in early November, potentially beating NASA's SLS to orbit. Mind you, SLS was supposed to launch in 2016, so a lot of things have beat SLS into orbit. We'll bring you more updates as launch approaches. For now, though, this has been the Daily Space. You can find more information on all our stories, including images, at dailyspace.org. This show is brought to you thanks to the donations of myriad people. Right now, we're doing our fall fundraiser. Our goal is to raise $50,000 by December 1st. And the vast majority of you out there, you don't donate. And we get it. Times are hard. But if you are one of the folks doing okay right now, please help our team do okay going into the new year and donate at CosmoQuest.org. Thanks.